Hello. So today I wanted to make a kinematics physics engine in Desmos. So let's get right into it. So first we're gonna need a ball. Um, so this is the position X. This is the position Y. So we're also gonna need. So okay, normally I would put Vx and Vy probably for like a physics engine like this, but I feel like right now I really want to do something cool. So actually, also let me decrease this radius. It's too small. I feel like 0.4. So I'm gonna do something cool. I'm gonna make a second dot. Okay, see this, and I'm also gonna make it so that it can only update every 0.05. So rather than like just it's like nice numbers, so it'll looks pretty fluid, but it always ends in fives. I like that a lot better because then it's easier to get it like onto just by waving. See like that, pretty close to 2 and stuff. See, 2 2. That doesn't happen too often if you just like random stuff. Anyway, so now I'm gonna draw a line. So y equals p or y minus p v underscore py over p underscore x minus p or no v px times x minus p underscore x plus p underscore y. There we go. And then I guess I can make it so that it's like p underscore x less than v underscore p x. But then that would mean that this would always have to be to the right of the ball, because then that happens. So I can also add I guess I can also add this. So it's like so it's just a continuous like motion. Okay. So this is our slope of the line. So what we're gonna need is we need to get Vx from this and Vy. So Vx from this, Vx is gonna be, we're doing an angle, this is the angle right here to the horizontal. So that should be, let's see if we can just get the angle right. So arctan of that, but I'm gonna want that in degrees. So if this is like what? 45 degrees, okay. Because it's just the rise opposite over adjacent, so arctan, okay. So that's our angle in degrees. So then v underscore x equals, if this is our angle, then it's adjacent, so cosine arctan of that times v total. So we're gonna need a v total, but that's for later. That's gonna be sine because it's the rise. So we're gonna make sure that we're right too by doing getting to the vy sine. So this should we'll remove this. That should increase, and then it should decrease, and then it should increase. Okay, yep, that works actually really well. So we need v. Oh no, it should be v naught. V naught. That's because it's like okay. V naught, and then we're changing these to v naught as well. So, okay. Oops. Folder. Velocity interface. So, punch that in. Object. We're gonna put all the stuff in here. There, that cleans this up a bit. So, and then v naught equals 5. So now we have a v naught. We also need an a naught, but I'm gonna do a y. And since I'm not gonna add jerk, snap, crackle, and pop, there's not gonna be an a naught because the acceleration will not be changing. So ax is 0, ay is 9.81 meters per second. So now we need to figure out how to change the position based on the velocity. So we need to get, actually we just need to get the current velocity. So Vx is the integral from 0 to, okay, we're gonna need time too. Now we're gonna need time. T equals 0. Now here's where it gets, because we're gonna add a ticker as well. So the Vx is from 0 to t of a of x dt. I know that you can just do v, you can just do the kinematic equation, v equals at plus v naught x, but I like it this way better because it's just easier to alter for this specifically. Also, it looks cooler, so sue me. Oh wait, we don't need to add the plus because the plus is already there. Wait, no, it isn't. That's the delta v. Lordy. It's been a bit since I've done physics or calculus. A few months, as a matter of fact. So, what is not working right now? Why is it a line? So, okay, first we're gonna add t increases by t turns into t plus 1 every, okay, I would say t equals t plus 1 every 1,000, so t equals t plus 0.1 every 100 milliseconds. Okay. 100 milliseconds. So, what is going on here? Okay, I thought so. So then what's the... I'm so confused. Plus v0x. v0... Oh, that's what it is. Vx... Okay, here we go. Yeah, okay. Let's say the acceleration is... I'm gonna just make the bouncer here. I don't think I'll ever need to accelerate upwards. So let's run this. It should not change at all. Perfect. So reset equals t goes to 0. So pull it to the top. Bam. So also t should never be negative. So there we go. Then we're gonna need to change position. So delta x is equal to the integral from 0 to t of vx dx plus p. I need to have a p0x. Px naught, because that's the same format I did last time. So p, why not? So p underscore x. When we reset, we should put everything back where it was. So that means that everything should go to its initial state. So if we move these around, like as though the thing was working, reset, go back to normal. Okay, and then we're also going to need to pull these out because this is what the user is going to be changing. So we're going to need to move these into like where all the variables are. And I'm going to keep it in order of integration, like position, velocity, and acceleration. So this is dx. Well, okay, I say dx, not dx is in the integral type of dx. I mean dx is in delta x, is what I mean by that. It's not even instantaneous delta x. This is just delta x over 0 to t. So I don't even know why I put dx. It's just like d for delta. That just makes sense. So dx is equal to vx, and then we're going to add the initial thing, and that's going to be the final position. Okay, yeah. So then every 100 milliseconds, px approaches px plus dx. No, px not plus dx. And dy for everything. Okay, let's reset everything. So let's say, okay, let's get everything set up. So we're going to have 9.81 meters per second of acceleration. Let's get these also up here. Okay. All these integrals look good. So, okay. Let's say we want to shoot it. Oh, wait, whoa, 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 whoa. Actually, I just realized something very stupid of me. Silly of me. V naught here. So V naught should just be so the distance between this and this, so that you can get like a kind of a feel for how far you want it to go. So the distance between those two is going to be what? So a squared plus b squared equals c squared. So distance equals the square root of a squared, which is vpx minus px naught, because this is going to be in the beginning, squared plus vpy minus py naught. So then we, yeah, okay. I like that a lot more. Maybe even 2 times that, like, so that it can like, you could have it, okay, we'll see what we'll adjust that coefficient later. Okay, everything seems good. So we're gonna just launch a ball up. What is happening? Oh, it's constantly updating, isn't it? Yep, that's what it is. It's constantly updating. Lord, that makes a lot of sense. Reset. Maybe I give it too much. Oh, let's also make this a little bit less jagged. Oh my god, I gave it an upward acceleration. Maybe it does need that, maybe sometimes. Should be negative 9.8. I got too used to my physics with where it's like, just assume the place you're going is positive and it makes math easier. Hey, okay. That actually was so let's give it like a launch. Let's give it like a launch. Hey, there we go. And how about let's clean up. Velocity interface, I can just put in there. Folder math. Crap. So we can put all that in there. So we got that done. Now we're just gonna goof off. So first, let's actually get the velocity interface to turn off whenever it starts moving. So that means that so let's call k t greater than 0. If it's true, it should be 0. If it's not true, wait. If t is greater than 0, this should output 1, or this should output 0. Yeah. Okay. So then let's actually call this. Oh no, I use that too much. Let's call it C. I use C too. Let's call it Z. So we're gonna like just put this Z over Z. So that way, when t is less than 0, as in when you're setting this up, then it will return a just 1, so it doesn't affect the equation at all. But then once t starts, like once t is greater than 0, then it will return indefinite because it will be 0 over 0, which will be a nothing value, so it won't graph this line, so it won't be very distracting. So let's just see how. There we go. That looks a lot better. I like that a lot more. And we can also do that with the. Oops. So try that again. I like that a lot better. What we're also gonna want is a tracker. So like every single time something happens, I don't know if I want every 10 milliseconds. How about every 10? How about if we'll add another value. So like if let's say z1, or I'll call z2 because there's already a z. I don't want to be confusing. So z2 is if mod t3 equals 0, then output a 1 if not a 0. That way every three time checks, it should output, it should add a, okay, hang on. What I'm trying to do here is I'm adding a tracker so that every single so often, at a certain interval, the graph will plot wherever the ball just was, so it'll make an arc. So, but I don't want to do that every 10 milliseconds. So I'm just adding an if statement such that it increases the interval from 10 milliseconds to match only 30 milliseconds, because it gets to do it every 3 times, so 3 intervals, so 30 milliseconds. And I might increase it as you increase that later. But yeah, so what's happening here is we're going to do x1 becomes join x1 comma p x. X1 is defined, so I'll just call it PL actually. PLX. So PLX. You know what? I'll just call it PL, and I'll make it a list of points. So PL join PL and PX PY. There we go. And then we should graph pl.x. Oops. Okay, that's not gonna work. We're just gonna do this. We're just gonna do just that we can graph it. So let's run this. Ooh, that's going slower. That's being a little profligate with our resources. And it didn't delete. So yeah, we need to clear PL. So reset. There we go. So let's say 1 in every 10. I like that, but I would rather 11, honestly. Or 12 even. So every 12, so every 120 milliseconds it should update at home. I like this a lot. And okay, I gotta add one more thing. We should have it so that you can save, or no. We're gonna have a save file. So every time you press save, it should be PL, or no. So the save file becomes, it approaches whatever PL is. So I'm also gonna move this up to the user interface area. So run, la 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 la. That's weird. That's not running as efficiently as it was earlier. Make that 15, no, 20, honestly. So we're gonna do that. Let's just reset it. So, okay. Here we go. Is that changing anything? Oh wait, is T ever even in a multiple of 3? If it's updating every... I feel like it's not. Okay, wait. Mod of what? 0.01 and 40 is probably just gonna be, yeah, 0.01. Oh, it's always gonna be less than that, probably. Oh, wait. Oh, wait, of course it's always gonna divide evenly. Actually, let's reset. Oh! Let's just say... What is T on right now? T's on 0.055, so what? 0.551. That's when it should update, and then otherwise not. So 0.03, I imagine, is what I should do. That is exactly, that's what was the, that's... Okay. That's what I wanted initially. Lordy. So anyway, oh, we also need this for the save file. Yaka. There we go. We launch it. Okay. Let's save this, reset it, and let's launch it totally different. We're gonna give it an acceleration lower. Launch it lower as well. So then, bam. Now we can have 2 different things. I bet you could also add ground, where if it makes contact, um, then you stop it. I bet you could also, I mean, I could add a display here. You could have it so you can change the color of the save files. You can have it so that you can name the save, like you can like organize them. This feels like it could be pretty be cool actually. So I'm gonna. I mean, I can update this later if anyone even watches it. I doubt anyone will. I mean, I just make these for fun, so I don't really mind. But for now, this is it. I mean, I can update it. I mean, I might update it later. Who knows? But like, this seems like a pretty good stopping point. I'm probably gonna go play Fortnite with my friends later. So, hope you all enjoyed me goofing off in Desmos. Bye.